Okay, good afternoon, grade 11s. I'm sure that you are also looking forward to coming back to school next week or the week after that. But in the meantime, I will help you that you can just work a little bit, that you don't fall behind with your maths. Okay, what I decided to um, discuss today and tomorrow is trigonometry. Today, reduction formula, and tomorrow general solutions, so solve equations. Now, I just want to tell you, if you want to ask a question, just unmute your mic and then you can ask. And then the lesson is recorded, so it will be available after the session on Ligbron Online School if you have to watch it again. Okay, so I'm going to give you time to just copy the sum and then we will do it. So the first one, I gave you tan 360 plus theta times cos of minus theta over cos of 360 minus theta. And I'm asking you to simplify. Now, if you see anything like this, and if we're doing the trig equations tomorrow, what you start with is always the set of axes. So you quickly make a drawing with 0, 90, 180, 270, and 360, like we've learned in our last online class, quadrant 1, 2, 3, 4. And you know by now that you can write any angle in two different ways. In the first quadrant, it's just the acute angle, or it's 90 minus another acute angle. Second quadrant, you can write an angle as 90 plus an acute angle, or 180 minus an acute angle. Third quadrant, you can write an angle as 180 plus an acute angle, or 270 minus an acute angle. Fourth quadrant, 270 plus or 360 minus an acute angle. Why is this important? You must know where you are working, because you remember all students take chances, meaning all ratios are positive in the first quadrant, only sine and its inverse, cosec, positive in the second quadrant, only tan and cot positive in the third quadrant, and only cos and sec positive in the fourth quadrant. Okay. And then later we will use the special triangles, but that I will draw now. So if you get reductions that you must do, like the examples that I'm going to do today, make sure that this set of axes is on your paper, on your page where you can see it, because you're going to use it all the time. Okay, so if I do number A now, you need to ask 3 questions. Now I'm going to write the 3 questions first. So the 3 questions that you're going to ask is, where is that angle? In other words, which quadrant? Quadrant 1, 2, 3, or 4? What's the sign in that specific quadrant? So say you're in quadrant 3, then only tan is positive. All the others are negative. So you must know where you're working so that you can decide on the sign of the answer. And question 3, you will understand now. I'm asking, is there a thief that wants to rob you of your marks? The thief is when you see a 90 plus or minus, or a 270 plus or minus. 270 plus or minus. Because if you see 90 or 270 plus or minus, then you must use cofunctions. Now I show it on my board in my class. I show this axis as a red axis. You know, the red means danger. So if you see a 90 minus or a 90 plus, or a 270 minus or a 270 plus, you must know that there's a thief and you must use cofunctions. Now, what are the cofunctions? Cofunctions, sine become cos, or cos become sine. Tan become cot, and cot become tan. and sec become cosec, or cosec changes to sec. You will see the cos there. So cofunction means you just add a co, or take a co away from your function. Because I don't know if you know that sin actually stands for sine, and cos means cosine. So sine, cosine. Tangent, cotangent. And secants, cosecants. Okay, so that's the cofunctions, and we will do examples with that as well. And then the only other thing that you must remember, or it helps if you know it, this is the positive way of direction of measuring, and this is the negative direction of measuring. And what's quite helpful is if you understand that you are in the fourth quadrant, say that angle, excuse me, is theta. Now, if you just go in the opposite direction and you measure the same angle, but in the negative direction, it's minus theta. So if you have an acute angle and you just put a minus in front of it, you are in the fourth quadrant. So what's helpful to know is if you're asked sine minus theta, it changes to minus sine theta. But why? Because minus theta is in the first quadrant, minus theta is in the fourth quadrant, and sine in the fourth quadrant is, we said, negative. But if you have a cos minus theta, where's minus theta? It's in the fourth quadrant, and in the fourth quadrant, cos is positive. So cos minus theta is the same as cos positive theta. Don't say I'm taking out the minus and put it in front. It's not true. Can you see? You ask the questions, where are you? In which quadrant? So what's the sign? Cos in the fourth quadrant is positive. And then if I give you a tan of minus theta, where are you? Minus theta is in the fourth quadrant. In the fourth quadrant, tan is negative, so it changes to negative tan theta. And if you have negative angles, I'm just giving you a quick summary of our last lesson. If you have negative angles, what's the thing that you can do? You can say, okay, if it's an acute angle, I can do what I did here, because then I'm in the fourth quadrant for all my questions. Otherwise, if it's any other negative angle, all you do is add 360 degrees. Because if I give you an angle of, say, minus 30 degrees, what happens if you add 360? You walk in a full circle. So from there, you will walk in a full circle. Where do you end? In the same place again. So any negative angle, you can just add 360 because you're ending in the same place. That's the same as 330. And can you see? Minus 30 is in the fourth quadrant, and 300 is also in the fourth quadrant. And then you carry on as usual. The same for angles bigger than 360. Angles that's larger than 360. What do? Just subtract 360. Because 360 means you're walking in a full circle. So if you have, say, 400 degrees. If you have 400 degrees, if you want to know where's 400 degrees, just subtract 360. And then you will see about 400 minus 360 equals 40 degrees. So if I give you a 40-degree angle there, and I'm walking 360 degrees in the positive direction, I'm also ending at 400 degrees. So it's different ways of writing the same thing. Okay, now let's start practicing. So there's your two sums again. So the three questions. And remember, you have now your set of axes in front of you. You have um, everything that you need and the three questions. So my first question is, where is this angle? 360 plus theta. Now, where's 360? 360 means you started at 0, you went once around in a full circle, there's 360, and now you add theta. So can you see that you're in the first quadrant again? So that's in the first quadrant. In the first quadrant, all the signs are positive, so it just reduces to tan theta times cos minus theta. My three questions, where's minus theta? Minus theta, you know by now, is in the fourth quadrant. Or if you want to say, I don't know where's minus theta and what can I do with negative angles? If I see a negative angle, I just add 360. So if I add 360, can you see that I can rewrite that as 360 minus theta? And can you see that you're back in the fourth quadrant? So cos of minus theta or cos of 360 minus theta, cos in the fourth quadrant is positive. So it becomes positive cos theta. Positive cos theta. My last one, where's 360 minus? 360 minus is in the fourth quadrant. What's the sign of cos in the fourth quadrant? It's positive. So cos theta. So now I reduced. And remember, you're going to get marks only if your signs are correct. So it's a plus tan theta, plus cos theta, and a plus cos theta. 3 marks already. And now you can just simplify. And simplify means these times and divide only, so you can most cancel. So this cos and that cos will cancel, and you're only left with tan theta. Okay. Now here you don't see 90s or 270s, so there's no thieves here. We will come to the thieves later. Okay, let's do number B. Sine 180 minus x minus sine of minus x over 360, sine of 360 plus x. Okay, my three questions. Where's 180 minus x? It's in the second quadrant. What's the sign of sine in the second quadrant? It's still positive, so that reduces to positive sine x. Now the difference between A and B, for A you had a multiplication there, and here you have a minus. So take note that you don't miss something. So there's the minus. Now I'm reducing sine minus x. Three questions. Okay, where's minus x? It's in the fourth quadrant. Or if you don't know, then add 360 there. Where's 360 minus x? It's still in the fourth quadrant. Sine in the fourth quadrant is negative. So it becomes negative sine x over. Where's 360 plus x? 360 is the same as 0. 0 plus x, you're in the first quadrant. The sign of sine in the first quadrant is positive. Everything in the first quadrant is positive. So it is positive sine x. Now, please remember, you cannot cancel because there's a minus. So if you times that minus with that minus, you get sine x plus sine x over sine x. And sine x plus sine x is 2 sine x over sine x. And can you see that the sine x is cancelled and your answer will simply be 2. So make sure that you don't confuse multiplication with a add or a subtract. Okay, I'm not going to do all the sums. I've given you some extras, sums that are much similar. I'm going to leave out. So I'm going to leave out number C and I'm going to do number D. If there's time at the end of the class, I will come back, but you will be able to do it yourself in any case. Okay, now why I chose this one is 720. Where's 720? 720 is just twice around from 0. Okay. Can you remember what we said now? What do you do with angles larger than 360? You just subtract 360 until you know what to do. So if I have 720 plus theta, I can subtract 360. Because 360 means if I walk in a full circle, I will end at the same place. So that changes to 360 plus theta. Now, 360 is once around the axis, and there's theta. Or if you want to, and you subtract another 360, you get 0 plus theta. So that's just theta. So that also tells you that you're in the first quadrant. So first question, where's the 720 plus theta? It's in the first question, first quadrant. What's the sign? Well, everything in the first quadrant is positive, so that changes to positive cos theta. This one again, take note, there's a minus, so keep the minus there. Now, cos of minus theta. Where's this angle? Minus theta is in the fourth quadrant, you know it by now. What's cos in the fourth quadrant? It's positive, so it's minus cos theta over 180 minus, where's that angle? It's the second quadrant. Tan in the second quadrant is negative tan theta. Now remember I said you only get marks if your sign is also correct. If you make sign mistakes, you're going to lose that mark. Now what happens now? Cos theta minus cos theta is 0. And 0 divided by anything is just 0. Okay. Okay, let's carry on. Now the reason I chose number E, you will see just now, but let's ask our questions first. 180 minus A is in the second quadrant. Sign in the second quadrant is negative. So it changes to it's positive. Sign in the second quadrant is positive. So sign A. Cos minus A, you know by now. Minus A is in the fourth quadrant and cos in the fourth quadrant is positive. 360 minus A is in the fourth quadrant. Sign in the fourth quadrant is negative. So it becomes negative sign A. Now this last one, A minus 180. You don't like the order. Now you cannot just swap it. The question is, where is that angle? Now, if you want to find out where is A minus 180, to correct the form of the sum, you want the 90 or the 180 or the 270 or the 360 to stand in front of the A or the theta or the X. So you don't like that A minus 180. So what you do is just simply add 360. Because minus 180 plus 360 will give you 180. And now there's a plus in front of that A. So that changes to 180 plus A. And where's 180 plus A? That angle is in the third quadrant. If you look at your set of axes again, where's 180 plus? 180 plus is in the third quadrant. So now you know this angle is in the third quadrant. What's the sign of cos in the third quadrant? It's negative, so this becomes a negative cos A. 4 marks already, if your signs are correct. And now I'm going to check if I can simplify. Because there's only times and divide, I can cancel. So a sine and a sine cancel, a cos and a cos cancel. But now I must still look at the signs. A plus times a plus is a plus. A minus times a minus is a plus. The plus divided by a plus is a plus. So your final answer will be plus 1. Now let's look at number F. Tan minus x plus 180 sine x minus 360 over sine 360 minus x. Now I don't like the order. I don't like it to be minus x plus 180. But can I rewrite it as plus 180 minus x? Yes, I can. So I'm just carrying here on here. So I'm just going to fix the order. Minus x plus 180 is exactly the same as 180 minus x. But now this one, I can write minus 360 plus x, but I don't like that. So I'm going to add 360 there. Because if you add or subtract 360, nothing changes. So can you see this one just changes to sine x, because the minus 360 plus 360 just fall away. So I'm in quadrant 1 actually. Over, and then this one 360 minus x is the fourth quadrant again. Sine in the fourth quadrant is negative, so I'm left with negative sine x.
So can you please re-explain number F?
Number F, okay. Let me start again. Can you remember if I say 2 plus 3, that's going to give me 5. Can I swap? Yes, it's a plus and a plus. So I can write it as plus 3 plus 2. That's still 5. Okay. But now, if I have minus 2 plus 3, I can write the plus 3 first and the minus 2 second. So that will change to 3 minus 2, because I just wrote the 3 first. Okay, so 3 minus 2 is plus 1 and 3 minus 2 is plus 1. So this is like the minus x plus 180. So if I compare this with minus x plus 80, I'm just going to write the 180, the plus 180 in front, and I'm just going to add the minus x. Okay, so I just wrote this one in front here. Minus x plus 180 is the same as 180 minus x. So this one I can write as tan 180 minus x. Now x minus 360. If I want to know where's x minus 360, I can do one of two things. X minus 360. Where's x minus 360? Well, where's x? X is an acute angle in the first quadrant. Now, what happens if I subtract 360? That means I'm going in the negative direction and I'm ending there in the first quadrant again. Or if I don't like this minus 360, just add 360. Can you remember I said, if you subtract or add 360, nothing changes. So minus 360 plus 360 just fall away, and I'm ending with x. So this one changes to sine x. And now I can carry on to the denominator. 360 minus is in the fourth quadrant again. And sine in the fourth quadrant is negative. So that one I can somewhat change to negative sin x. And now I can say, okay, what happens to 180 minus x? Where's the angle? It's in the second quadrant. What's the sign of tan in the second quadrant? It's negative. Tan x sine x over negative sine x. Can you see that the minuses cancel, the sine x's cancel, and my final answer is just tan x. Okay. Okay, number G, I'm not going to do. I'm going to do number H because number H is more difficult. Now, what you see here that we haven't seen before is a square. Sine square 180 plus. Now, you remember that a square is always positive. Doesn't matter if I give you 3 square, that will give you 9. If I ask you minus 3 squared, it will give you positive 9. Okay? If I give you minus 3 square, the 3 square is positive. But then I must multiply it with a minus. So that answer will be minus 9. If I ask you minus 3 square, that minus stays there. But what's the answer of this minus 3 square? That's positive 9. So what I'm telling you is whatever the sign in front there will stay the same. If there's a minus in front of that square or a minus in front of that square, the answer will, the sign will stay the same. Now remember, you first square before you multiply. You cannot say, I must first multiply and then square. That's wrong, because then you square where you're not supposed to square. Okay? First, I teach my learners powers are more powerful than anything else. So you're going to do the powers first. Okay. So look what happens here. Okay, and you remember that sine square b is the same as the square of sine b. You remember that? Okay, that's important. The only reason why we don't put the square there is because it looks like we're squaring the angle, and that doesn't make sense. Okay. So if you see sine square 180 plus b, just remember it will be the square of sine 180 plus b. Now what's 180 plus b? Where is that? Question side stay the same. Where is that angle? It's in the third quadrant. Sine in the third quadrant is negative. Negative sine b. But if you're going to square it, can you see that it's going to change to positive sine square b? Because the square is always positive. Okay. The next function also looks, the next ratio, strange. Minus b minus 180. I don't know where's that. So the easiest way is to just add 360 there. Sorry, the bracket fell away there. Just add 360. Because what's minus 180? Minus 180 plus 360 is 180. So I'm just writing this answer in front here, and then I'm going to add the minus b there. And in the denominator again, I don't like b minus 360. But you know by now, if I just add 360, then I know where I am. Minus 360 plus 360 just fall away, and I'm left with sine b. The last one is easy because 180 minus b is in the second quadrant again, and cos in the second quadrant is negative. Okay, I still have some simplification to do. So we said now this minus sine b squared become positive sine square beta. Okay, let's carry on. Cos 180 minus. Now I can say, well, I know this is in the second quadrant. Cos in the second quadrant is negative. The reason why I put it in brackets is that I don't forget that I'm actually busy with multiplication there. And then I already have sine B and I have minus cos B, and I see if I can simplify. Can I cancel? Yes, I can. Cos B cancel, minus and a minus cancel, and sine B goes into sine square B, sine B times. There's only one sine B left at the top. Okay, number I, I'm going to leave out for now. I'm going to carry on to number M. Sine A minus 540 degrees over cos 180 plus A plus sine of minus A over cos of 360 plus A. Okay. Now the first one, A minus 540. I don't know where that is. So I'm going to add 360. I'm going to add 360. Let's simplify that first. A minus 540. If I add 360, I get A minus 180. Well, I still don't like that order because I want the 180 to be in front. So I can add another 360. So now I have A minus 180 plus 360 is plus 180. And can you see that's the same as 180 plus A? So this sine A minus 540 become the same as sine 180 plus A. I just simplified it so that I can know where I am working. Cos 180 plus A, where's 180 plus A? It's in the third quadrant. Cos in the third quadrant is minus. Plus sine minus A. Minus A, you know by now, is in the fourth quadrant. In the fourth quadrant, sine is negative. 360 plus. 360 plus is in the first quadrant again. Because 0 and 360 is the same place, eh? So everything in the first quadrant is positive, so I have that. Okay, let's simplify. Sine 180 plus, now I know that's in the third quadrant. Sine in the third quadrant is negative, so it's negative sine A over negative cos A. And then that plus and that minus will give me a minus sine A over cos A. Now you know that a minus divided by a minus changes to a plus. They cancel. And because I must add or subtract fractions, you remember that we must get the LCD. And I have the LCD already. I have a cos there and a cos there. So I have the denominator already, the LCD. So now that becomes sine A minus sine A on top over cos A. And what's sine A minus sine A? It's 0. And 0 divided by anything still give me 0. Okay, Now, what you see there is all of a sudden there's a 90 and a 90. Okay, you can first copy sine of 90 plus beta times tan of minus beta minus sine of beta minus 90 degrees times tan 180 minus beta over tan 360 minus beta. Okay, let's ask our three questions now. Where's 90 plus? Now, okay, I'm just going to draw a little quick new sketch here. 0, 90, 180, 270, 360. 90 minus or plus, 270 minus or plus. Now, where's 90 plus beta? 90 plus is in the second quadrant. And so this is the second quadrant. So first question, where? Second question, what's the sign? The sign of sine in the second quadrant is positive. But now, is there a thief? Now we get to the third question. Yes, there is a thief because the 90 plus is the thief. Can you remember I said this is the bad axis, the danger one? Because if I have a 90 plus or minus or a 270 plus or minus, I must use cofunctions. And the one that we're going to use the most is sine changes to cos and cos changes to sine. So now there's a thief. So now this sine must change to a cos beta. Okay, that's very important. Tan minus beta, fourth quadrant, tan in the fourth quadrant is negative, so that's negative tan beta. Okay, there's the minus, there's a minus. Sine beta minus 90. Now, I don't like the order. I want the degrees to stand in front. So what am I going to do? I'm going to add 360 here. So what's 360 minus 90? It's 270. So this whole angle here changes to 270 plus beta. But it's the same. It's the same angle. So now I know 270 plus beta is in the 270 plus is in the fourth quadrant. Fourth quadrant and the fourth quadrant. And in the fourth quadrant, only cos is positive. So that's the fourth quadrant where sine is negative. But there's a thief. So the thief tells me the sine must change to cos. So it must change to minus cos beta. Tan 180 minus, second quadrant where tan is negative. There's no thief, so it stays tan. And then my denominator 360 minus in the fourth quadrant. Tan in the fourth quadrant is negative. There's no thief, so it stays tan beta. Now I'm just going to simplify. Plus times a minus is a minus. Cos beta, tan beta. Minus, minus, minus. Minus times a minus is a plus, times a minus is a minus. Cos beta, tan beta. Over minus tan beta. On top I have a minus, I subtract. So minus cos beta tan beta minus another of the same will give me a minus 2 cos beta tan beta over minus tan beta. And can you see the tan betas cancel, the negatives cancel, and I'm left with a 2 cos beta. Okay, I'm going to leave you with this. I'm going to leave this one that I can get to the actual sizes of the angles. Okay, let's go to the angles now. The question is still simplify, and it's without a calculator. It's still without a calculator. So the same questions apply. I first want to find out where's that angle. 225 is in the second quadrant. Now, you always going to try to write an angle. If I use my set of axes again, remember you don't like this bad axis. So you're avoiding it wherever you can. So you're going to try and write whatever you have as 180 minus an acute angle, 180 plus an acute angle, or 360 minus an acute angle. That's what you're going to try to do. So where's 2 to 5? It's not in the second quadrant, it's in the third quadrant. It's here. So 2 to 5 is 180 plus 45. Okay, there's a question, Lenovo. Can you can ask?
Yes, ma'am, I have a problem with 225. It looked like it's on quadrant 3.
Yes, it's on quadrant 3. So it is, I started saying the second quadrant, but that's wrong. It's in the third quadrant. It's 180 plus 45. Do you agree with me? So now I can write that tan 225 as tan 180 plus 45. I will carry on just now. Let's just finish this tan. I know this is in the third quadrant where tan is positive. So this tan 180 plus 45 will change to tan 45. Okay. Now let's go to the next one. Plus cos minus 60. Where's that minus 60? You know that minus 60 is in the fourth quadrant. And you know that all students take chances. In the fourth quadrant, cos is positive. So do I have cos here? So it's fourth quadrant. Cos is positive there, so that will change to plus cos 60. And then I'm doing this 510. I don't know where's 510. So if you have angles larger than 360, what are you going to do with the 510? You're going to subtract 360. So that will give you 150. So sine 510 is the same as sine square of 150. And now you can say, okay, 150 is in the second quadrant. So I can write it as 150 as 180 minus 30. And now I can carry on. Now, where will I find the answers for 45 and 60 and 30? Can you remember your special triangles? The 30 angle is there and the 60 angle is there. Can you remember the sides? Sine of 30 is opposite over hypotenuse. Sine of 30 is a half. So it's 1, 2, and there you have square root of 3. Do you know your 3 triangles? Now, I'll say something about that just now. The 45 and the 45 will be there. And then those two sides are equal because these two angles are equal. And then this hypotenuse will be square root of 2. Now I'm going to say something that the examiners know, and if I tell you that if you see a special angle or a 0, 90, 180, 270 or 360, just type it in your calculator, because nobody will know if you actually use the triangles or not. They will not know, because you're supposed to know that. So if you just type it in your calculator, they will think that you use it from your sketches. Okay, so that's just a little tip. So tan 45, you go to the sketch, tan is opposite over adjacent, so it's 1 over 1. Tan 45 is 1. Cos of 60, adjacent over hypotenuse is a half, minus. Now sine of 180 minus 30. Okay, let's simplify it first. That's in the second quadrant. Second quadrant, sine is positive in any case. So that can change to sine 30, and you must square the answer, although it is positive in any case. So what's sine 30? Sine 30 is a half. Sine opposite over hypotenuse. But now you must remember you must square this answer. And this gives you 1 plus a half minus a quarter. And that will give you 1 and a quarter or 5 over 4. Doesn't matter, any one of the two will do. So that's what you will do with special triangles. Or with actual angles, you try to write it as special angles. Okay, now for number F, I'm just going to take a clean screen because we don't have enough space there. I'm just going to rewrite it. Sine 168 minus cos 78 plus tan of minus 45. Is there a question again? Okay. Okay, it's actual angles. Now here you will see, remember the question was without a calculator. So if you just look at the sum for a moment, you will see a 78 there. 78 is definitely not a special angle. So that means that something in the sum will cancel with this cos 78. Now, if you see that, you immediately think of cofunctions. Cofunctions. So that cos 78, I can do nothing about. It just stays cos 78. Now let's look at this sine 168. The first question is where? That angle 168 is in the second quadrant. Now if I can explain here, 168, I can write 168 as 90 plus what will give me 168? 90 plus 78. Or I can write it, because it's in the second quadrant, I can write it as 180 minus, and that will give you a 12. Now can you see, there's a 78 and there's a 78. So now you are forced to use the bad axis. So you're going to write this 168 as 90 plus 78. Why? Because you have a 78 there already. And you know, this is in the second quadrant. Sine in the second quadrant is positive. But because there's a 90 plus, that means there's a thief. So I must change that sine to cos 78. So can you see, you are forced to change to cofunction. You don't like it, but you don't have another choice, because can you see what's going to happen here? The cos 78 minus the cos 78 will fall away. And now I just carry on with the tan minus 45. That's in the fourth quadrant. Tan in the fourth quadrant is negative, so minus tan 45. Minus tan 45, let's write it there, because now I can say tan 45 is 1 again. And can you see what happens? Cos 78 minus cos 78 just fall away, and I'm left with a minus 1. So sometimes you're forced to use cofunctions, and then it will be so that something will cancel. That odd angle, which is not a special angle, will either cancel numerator and denominator, or it will fall away because you plus and minus with the same function. Okay. Let's look take a look at number G. Tan 240 sine 115 over cos 330 times cos 205. Three questions. Where is 240? 240 is in the third quadrant, again. So in the third quadrant, I can write an angle as 180 plus, and you see that it will be 60, and you like that because 60 is a special angle. Now sine 115. 115 is in the second quadrant. Now in the second quadrant, you can write it as 180 minus what will give you 115? It will be a 65. $330 is in the fourth quadrant, so you can write it as 360 minus 30. And 205, now 205, I'm going to show you here, 205 is in the third quadrant again. So you can write it as 180 plus one or other acute angle, or as 270 minus one or other acute angle. Now 180 plus 25 will give you 205, or 270 minus 65 will give you 205. Now you don't like the 270, but look here, you have a 65 there already. That's what tells you you're going to use that one where the 65 is. So you're going to write this 205 as 270 minus 65. Can you see why? Because there's a 65, and you think that they're going to cancel because it's not special angles. Okay, now we simplify further. Third quadrant, tan in the third quadrant is positive, so that changes to tan 60. 180 minus in the second quadrant, sine in the second quadrant is positive, so that stays sine 65. 360 minus, still fourth quadrant, cos in the fourth quadrant is positive, so that changed to cos 30. 270 minus, third quadrant, so cos in the third quadrant is negative, but there's a thief. Remember, there's the thief. So the cos must change to a sine 65. And can you see why that's important? Because now you can see the sine 65 and the sine 65 will cancel because they're not special angles. I can do nothing else with them. Now I just simplify further. My special triangles, tan 60, tan opposite over adjacent. So tan 60 is square root of 3 over 1. Cos of 30, square root of 3 over 2. But there's a minus still, so there will be a minus in front. And you know how to divide with fractions. Divide, this divide, become a times, and this fraction swaps. Minus 2 over square root of 3. Square roots of 3 cancel, and my answer will be minus 2. And what looks like a difficult sum is really not difficult if you follow your 3 questions and you write as I say. Okay, let's see. We have time. I think we have time for one more sum. Let's take number J. Sine minus 45, cos 315, cos 215, sine over sine 305, tan 75 times tan minus 300. Okay. Sine minus 45, fourth quadrant. Sine is negative in the fourth quadrant, changes to minus sine 45. 315 I can write as 360 minus 45 because it's in the fourth quadrant. 215 is in the third quadrant. So I can write it as 180 plus 35. $305 is in the in the fourth quadrant, so I can write it as 360 minus 55, but I don't have a 55 on top, I have a 35. So look at that 305. If you write it in two different ways, you can write it as 270 plus 35, or as 360 minus. Now, can you see where you're going to get the 35 from? So I'm going to write that 305 in the fourth quadrant as sine 270 plus 35. Why? Because I have another 35 already. That's why I'm choosing that option. 750. Angles larger than 360. Subtract 360. Subtract 360 again. So I'm going to subtract 360 and I'm going to subtract 360 again because then I'm left with tan 30. And you know where's that? What am I going to do with this minus 300? Well, I don't like negative angles. So just add 360. And 360 minus 300 is 60 again. Okay, so I can simplify so long. Sine 45 special angle is minus 1 over square root of 2. 360 minus 45, that's in the fourth quadrant. So it becomes cos 45. What's cos 45? Let me just write there, cos 45. And then cos 180 plus 35. That's in the third quadrant. Cos in the third quadrant is negative. So it changes to negative cos 35. Now 270 plus, it's in the fourth quadrant. I know that sine in the fourth quadrant is negative. But now, can you see the thief trying to rob you from your marks because he wants you to forget to change the sign to a cos 35. Tan 30 from your previous sketch, tan is opposite over adjacent. So that is 1 over square root of 3. And then tan of 60, opposite over adjacent will give me square root of 3 over 1. If I simplify, I get 1 over square root of 2, but it's a minus. Cos 45 is another 1 over square root of 2. Can you see what happens here? Minus cos 35 minus cos 35. They cancel because I only have pluses and minuses. So you can see where you have angles that's not special angles, they will just cancel. And if I go to the denominator now, can you see those two cancel? And I have a 1 there. So minus 1 over square root of 2 times 1 over square root of 2 will give me minus 1 over 2. Okay, that's all that we have time for. See you tomorrow, same time, same place. It was very nice seeing you and doing maths with you. Tomorrow we will do trig equations, general solutions. So keep well, wear your masks, wash your hands, and then we will see you tomorrow. Bye-bye.